All right, hello and welcome back. We're covering the Unit 7 review for our test. This is review number 1. All right, for the first question, we're going to graph the equation. We're going to find the X-intercepts, the vertical asymptotes, the horizontal asymptotes. We're also going to state the domain and the range. So first we want to factor the denominator. So that's going to factor into x plus 3 times x minus 3. All right, we'll go ahead and find the x-intercepts. The x-intercept is taking your numerator and setting it equal to 0. So if x minus 2 is 0, x is going to be 2. So we'll have an x-intercept at 2, 0. All right, and we just go ahead and place that on the graph. All right, our vertical asymptotes is when you set the denominator equal to 0. So if we have x plus 3 times x minus 3 equal to 0, then x is going to be negative 3, and also x will be positive 3. So we're going to have a vertical asymptote going through negative 3 and one going through positive 3. All right, so we've just drawn our two vertical asymptotes here. All right. Next we want to find the horizontal asymptote. Now the degree of the numerator is 1 and the degree of the denominator is 2. So when the numerator's degree is less than the denominator's degree, you have a horizontal asymptote, and it is y equals 0. All right, whenever the numerator's degree is less than the denominator's degree, your horizontal asymptote is y equals 0. So that is y equals 0 is just the x-axis. So we'll just draw the asymptote here. Okay. All right, now we can go for some extra points. So to find the extra points, we want to use our table. All right, you can see on the right that I've typed in the equation on the y equals line. And now I'm going to press the table button. And here's my table. Now, back over here on the graph, I want to find points that are to the left of negative 3. So maybe I'll choose negative 4 and maybe negative 6. All right, so based on the table, when x is negative 6, my y value is negative 0.296. When x is negative 4, my y value is negative 0.857. So I'm just writing those values here in the table. All right, let's choose some values that are close to negative 3 in this space. So maybe I'll choose negative 2 for x. So at negative 2, my y value is 0.8 based on the table. And when x is negative 1, my y value is 0.375. All right, let's pick some points that are to the right of positive 3. So points over here, let's go with maybe 4 and 6. So when x is 4, according to the table, the y value is 0.286, and when x is 6, the y value is 0.148. All right, let's plot these points on the graph. Okay, so negative 6 and then negative 2.96, negative 4 and down negative 0.8, negative 2 and up 0.8, negative 1 and up 0.37, positive 4, comma, and then up 0.286, and then over 6 and up 0.148. All right, when we draw our graph, we just draw the curves passing through our points and also drawing it so that they are very close to our vertical and horizontal asymptotes. Okay. Notice that this curve here in between the vertical asymptotes is actually passing through this horizontal asymptote, which is perfectly fine. All right, and then on the right side, we have a curve that looks like this. All right, and this is our complete graph. All right, let's state our domain and our range. Now we can see that the domain is going from negative infinity up until it gets to this vertical asymptote. So that's from negative infinity until it gets to -3. Okay, so domain is negative infinity to -3, union, and then it's going to go from -3 till it gets to the next vertical asymptote. So that's from -3 to +3. And then it's going to go from this +3 all the way out towards positive infinity. So union 3 to infinity. All right, now as far as the range goes, the range is going to start all the way down here. But if you notice this middle section, it's going to start down here from negative infinity. It passes through the horizontal asymptote and goes all the way up towards infinity. So that's one continuous curve. So our range is going to go from negative infinity to positive infinity. All right, and here we have our domain and our range. All right, for question number 2, we can factor the numerator. So the numerator would factor into x minus 5 times x plus 3, and the denominator remains the same. All right, let's find the x-intercepts. The x-intercept is setting the numerator to equal 0. Well, if the numerator is 0, then x would be positive 5 or x would be -3. All right, so x-intercepts is positive 5, 0 and -3, 0. And again, that's from setting the numerator equal to 0. All right, I'm going to go ahead and put those on the graph. 5, 0 and -3, 0. Okay, those are our two x-intercepts here. All right, let's find the vertical asymptote. Now, the vertical asymptote is when you set the denominator equal to 0. So the vertical asymptote is when x plus 1 is 0, which means x is -1. So let's draw a vertical asymptote passing through -1. All right, let's go ahead and find the horizontal asymptote and or slant asymptote. Well, because the numerator's degree is 2 and the denominator's degree is 1, the numerator's degree is 1 greater than the denominator. So in this case, we do not have a horizontal, but instead we have a slant asymptote. So to find the slant asymptote here, we are going to divide using synthetic. So we have -1 on the outside, and then our coefficients are 1, -2, -15. Drop the 1 down. 1 times -1 is -1. Add, you get -3. Multiply, you get 3. And add, you get -12. So our slant asymptote is going to be y equals 1x minus 3. And that's because the remainder is -12 over x plus 1, but that is going to go towards 0 when x goes towards infinity. So our slanted asymptote is this equation, y equals 1x minus 3. Let's go ahead and graph that. This has a y-intercept of -3 and a slope of 1. So we put a point at -3 on the y-axis, and then your slope is up 1 over 1, up 1 over 1, up 1 over 1, And so you just go ahead and draw this dashed line. All right, so this line is our slanted asymptote. Okay, next we're going to find some extra points. So let's go to our table. All right, now I want to pick a couple of x values that are to the left of this vertical asymptote. So I'm choosing -6 and -2, which I'm putting here in the table. So when x is -6, based on my calculator table, I see that my y value is -6.6. When x is -2, the y value is 7. Then I'm also choosing a couple of points that are to the right of this vertical asymptote. So I chose 0 and 8. According to my calculator table, when x is 0, y is -15. When x is 8, y is 3.67. All right, let's go ahead and plot those points. Okay, so the first point here, -6, comma, -6.6. That's down here. Okay, and then -2, and then up 7 would be there. All right, so I can go ahead and draw this curve, and that's going to be something like this, curving like that. Okay, all right, and now we have these other 2 points. That's 0, comma, -15, which is all the way down here somewhere. Okay, and then 8, comma, 3.67. All right, so we have this one down here, this one down here, and that one there. So we'll draw a graph passing through those 3 points. So maybe something like this, curving down like that. Okay, and that completes our graph. And now we also have to state our domain and our range. So the domain is going to be from -infinity until it gets to the vertical asymptote here at -1. So that would be from -infinity to -1, and then it will pick up again, so union -1 all the way to infinity. As far as the range goes, the range, well, let's say that you're on this curve here. If you're on this curve and you're traveling along this curve, you're coming from -infinity, and then this is going to keep going up forever towards positive infinity. So it's safe to say that our range is from -infinity to infinity. All right, and that completes number 2. All right, question 3. We're multiplying these 2 fractions together. The first thing you want to do is to factor everywhere possible. So x squared minus 4 can be factored into x plus 2 times x minus 2. And that'll be over x plus 3 times, and then this x squared plus 4x plus 3 can be factored into x plus 3 times x plus 1. And the 2x minus 4 would factor, you can factor out a 2, and that would be 2 times x minus 2. We're going to get the x minus 2's to cancel on the top and bottom. You're also going to get x plus 3's to cancel on the top and bottom. What's left over is x plus 2 times the x plus 1 on the top, and that's all divided by the 2 on the bottom. So we can say that this is our final answer. All right, here is question number 4, and we see that the problem is dividing, so we're dividing 2 fractions. When you divide 2 fractions, you change the division to multiplication, So I'm actually going to do that now, right here. Change that to multiplication, and then flip the second fraction. So the x minus 1 is now on the top, and 3x minus 6 is on the bottom. Okay, now the next step is to factor wherever possible. So the 4x minus 8 is going to factor into 4 times x minus 2. The denominator here will factor into, that'll be x minus 2 times x minus 1. The x minus 1 is already factored, so we leave that the way it is. And 3x minus 6, we can pull out a 3. So that would be 3 times x minus 2. All right, now since we've changed it to multiplication, then we can start cross-canceling common factors that are on the top and bottom. So let's go ahead and cancel out x minus 2's on the top and bottom. Let's also cancel out these x minus 1's that are on the top and bottom. And what we have left is on the top, looks like a 4. That's the only thing left on the top. And then on the bottom we have a coefficient of 3, and we also have a factor of x minus 2. So ladies and gentlemen, this is our final answer. That's 4 over 3 times x minus 2. For question 5, we are adding these two fractions. In order to add fractions, we must have a common denominator. So let's find the least common denominator. Well, you've got 6x and you've got 18x. And I think 18x is going to be our least common denominator because both 6 and 18 can go into 18. So least common denominator over here is 18x. So now when you're adding, you want to make sure that both fractions have the common denominator. And if they don't, you simply multiply by whatever's missing. So the fraction on the right already has our common denominator, so we can just leave that alone. But the fraction on the left is 6x in the denominator. We want to make it 18x. So to go from 6x to 18x, we would have to multiply the top and bottom by 3. So that's going to be 3 times 5 and 3 times 6x. Well, that would result in 15 over 18x. And then you have the second fraction is the same, 7 over 18x. And now we can just add the terms on the top. 15 plus 7 is 22. So that's 22 divided by 18x. And we can reduce that fraction to lowest terms. So reduced to lowest terms would be 11 over 9x. And that is our final answer there. All right, question number 6. We are subtracting two fractions. And again, we would need to have a common denominator. So over here on the right, let's determine what our common denominator is. The common denominator is going to be a combination of x minus 2 and x plus 1. So our least common denominator is x minus 2 times x plus 1. All right, and so then for each of these fractions, we multiply by whatever is missing. So the first fraction is missing the x plus 1. So that means we're going to multiply the top and bottom of that first fraction by x plus 1. The second fraction is missing x minus 2. So we're going to multiply the top and bottom of the second fraction by x minus 2. Now, when you distribute the x plus 1 times x minus 1 on the top, you're going to get x squared minus 1. This is the middle terms will cancel each other out. And that's going to be over your common denominator of x plus 1 times x minus 2. We bring down the minus sign that's in the middle. And then when you multiply the x minus 4 times x minus 2 in the second fraction, and you distribute that out, you're going to get x squared minus 6x plus 8. And that's going to be over your common denominator, x plus 1, x minus 2. Now we can simply combine like terms in the numerator, but remembering that there is a subtraction in the middle. So when you subtract the x squared minus this x squared, those are going to cancel each other out. You have a negative 1, and that's going to be minus an 8. So negative 1 minus 8 is going to be negative 9. You're also left with the negative 6x, but that's actually turns into positive, right? Because that's a double negative. So what you end up with on the top is positive 6x minus 9. And all of that will be over your common denominator of x plus 1 times x minus 2. Now you want to remember to make sure you factor as far as possible in the numerator in case you can cancel something out later. So we can actually factor out a 3 from the numerator. So we're going to get 3 times x minus 3 on the top. 3 times 2x minus 3 on the top, all over our common denominator. All right, and this, ladies and gentlemen, is your final answer. All right, for number 7, we want to factor this denominator first, and then we'll find the least common denominator. All right, so this x squared minus 10x plus 21, that will factor into x minus 7 times x minus 3. All right, let's determine our least common denominator now. Our least common denominator is going to be x minus 7 times x minus 3. Now, in this first fraction, the common denominator is already intact. There is nothing missing in this first fraction, so we don't need to multiply that first fraction by anything. However, in this second fraction, the second fraction is missing x minus 7. So let's multiply the top and bottom by x minus 7. Right, in the first fraction, it's going to remain 3x. So it'll be 3x over your LCD plus, then you'll distribute the 5 into the x minus 7, would be 5x minus 35, and that's also over your LCD. And now we can combine like terms, so we'll add 3x and 5x together, and that's going to give us 8x, and we also have the minus 35 on the end, and that's over our LCD, which is x minus 7 times x minus 3. All right, we cannot factor the numerator anymore, so this is our final answer. All right, here is number 8. Number 8, we have a complex fraction because we have fractions within a larger fraction. We want to get rid of these smaller fractions, and the way you do that is by multiplying by the least common denominator. So the least common denominator between x and x squared is x squared. So let's multiply everything by x squared. That's on the top and bottom. So distributing x squared times 1 is x squared. X squared times 3 over x is going to leave you with 3x. And that's because this x on the bottom cancels with one of those x's on the top, leaving you with x times 3. Okay, then in the denominator, x squared times 2 is 2x squared. And then x squared times 5 over x squared, well, that's going to cause these x squareds to cancel each other, leaving you with minus 5. We can then factor an x from the numerator, so that would be x times x plus 3 all over the same denominator. There's nothing left to factor and nothing left to cancel out, so that's our final answer. All right, here in number 9, we're adding these two fractions together, the three fractions together. And so first we want to factor the first denominator. That's going to factor into x plus 3 times x plus 3. And the second denominator can be factored into x plus 3 times x minus 3. And then in the third fraction, we just have x minus 3, which stands alone. So our least common denominator is going to be x plus 3 times x plus 3. That takes care of this denominator. But then we also need an x minus 3 for these two denominators. All right, so again, our least common denominator is x plus 3 times x plus 3 times x minus 3. So what we'll do next is we'll multiply each one of these fractions by whatever's missing to make the least common denominator happen. All right, let's start with the fraction on the far left. What's missing there is the x minus 3. So let's multiply the top and bottom by x minus 3. Okay, now what's missing in this second fraction is another x plus 3. So we're multiplying by x plus 3 on the top and bottom. And what's missing in this last fraction is an x plus 3 times another x plus 3. So x plus 3 times x plus 3 on the top and bottom. All right, let's go ahead and distribute this numerator together. And that's going to give us 2x squared minus 6x plus 5x minus 15. And that's going to be over our LCD. Let's distribute this numerator together. And we'll get x squared plus 3x. And that's over the LCD. And let's distribute all of this together. And that's going to give us x squared plus 6x plus 9. And that's over our LCD. Now let's combine like terms. 2x squared plus 1x squared plus 1x squared is 4x squared. Negative 6x plus 5x, that makes negative 1x. And then plus 3x, that's 2x. And then plus another 6, that's 8x. Then we combine the constants. That's negative 15 plus 9 is going to be negative 6. And all of that is over our LCD. Now, in the numerator, we can factor out a 2. So that's going to be 2 parentheses 2x squared plus 4x minus 3 all over our LCD. Okay, now we can attempt to try to factor this polynomial. So if you multiply 2 times negative 3, that's negative 6. But there's nothing that's going to multiply to negative 6, but also add up to the 4 in the middle. So this is not factorable. And so this is our final answer. But let's just bring back the LCD here on the bottom. So our final answer will be 2 times 2x squared plus 4x minus 3 all over the LCD, which is x plus 3 times x plus 3, or x plus 3 squared, times x minus 3. All right, here is number 10. Now we notice that between the first two fractions is division. Between the second two fractions is multiplication. And when we're dividing fractions, we change it to multiplication and flip the second fraction. So let's go ahead and do that. I'm going to change this division to multiplication. And then we're going to flip this fraction. So we're going to end up with 3x on the top and x minus 2 on the bottom. Now we have multiplication here and multiplication here. The next step would be to factor the first numerator. That's going to factor into x plus 2 times x plus 1. We can factor this numerator by pulling out a 2. That'll be 2 times x plus 2. We can factor this denominator by pulling out a 5x. So that's going to be 5x parentheses x minus 1. Okay, and now we can start canceling out the like terms that are on the top and bottom. For instance, we can cancel out this x plus 2 with that x plus 2. We can cancel out this x with that x. And that is all that we can cancel out. So let's see what we have left. We have this 2 and that 3 multiplied together. That's going to give us a 6 on the top. And then we have these two factors multiplied together. We'll just leave those in factored form. So x plus 2, x plus 1. Then in the denominator, what do we have left there? We have this 5, and we have this factor of x minus 2. So on the bottom, you'll just have 5, x minus 2. Oh yeah, we also have this factor of x minus 1. So we bring that down as well. And this, ladies and gentlemen, is our final answer. All right, so in the next page we are graphing, and we've got these two graphs to take care of. So graph number 1, we have the numerator can be factored. We'll go ahead and factor that. That's going to be pulling out a 2 first. It'll be x squared minus x minus 2 all over x squared plus 2x minus 8. And then we can factor that further. So in the numerator it's going to be x minus 2 times x plus 1. And the denominator will be x plus 4 times x minus 2. Now in the denominator we have the same factor that's also in the numerator, so those two terms are going to end up canceling each other out, and that means that there's going to be a whole, and the whole occurs when x minus 2 is equal to 0, which means when x is 2. Now we plug in x equals 2 to figure out the y value of the whole. So doing some mental math, we plug in the 2 there. 2 plus 1 is 3, times 2 is 6. And then on the bottom, you're plugging in 2 there, and that's 2 plus the 4 is also 6. And so we end up with y is going to equal 6 over 6, which is 1. So we're going to have a whole at 2 comma 1. Let's go ahead and put that on the graph. So over 2 and up 1 is our whole right here. All right, now let's find the x-intercept. To find the x-intercept, you can set the numerator to equal 0. Well, the numerator is this x plus 1 times the 2, but you can really just ignore the 2. So that's just going to be x plus 1 equals 0. So x plus 1 equals 0, which means x is going to be negative 1, which means your x-intercept is going to be negative 1 comma 0. Let's put that on the graph. And so your x-intercept is here, negative 1, 0. Okay. The y-intercept. All right, the y-intercept, you find that by plugging in 0 for all of the x's. And it's just as easy to actually do that in the original equation. If all of these x's are zeros, then you're just left with negative 4 divided by negative 8, which is positive 1/2. So that means we're going to have a y-intercept of 0 comma negative, or 0 comma 1/2. 0 comma 1/2 is our y-intercept. All right, let's go ahead and put that on the graph. 0 comma 1/2 is right about in here. All right. What else do we need? We need vertical asymptotes. To get the vertical asymptotes, we set the denominator to equal 0. So we can use this denominator, x plus 4. So if x plus 4 is 0, we get x is equal to negative 4. So we have a vertical asymptote at negative 4. Let's go ahead and draw that in. So here's negative 4, and we just have our vertical asymptote. All right. Next, let's find the horizontal or slant asymptotes. We do that by looking at the degree of the numerator and the denominator. The degree of the numerator is 2, degree of the denominator is 2. So when the degrees are the same, the horizontal asymptote is the ratio of the coefficients. So that's y equals coefficient of 2 divided by coefficient 1. That's 2 over 1, which means y equals 2 is our horizontal asymptote. So on the graph, let's draw a horizontal line going through y equals 2. All right. So we've got horizontal, vertical. Let's see, what else do we need? I think that's it for now. Let's go ahead and plot some extra points. So we're going to use a table. Use the table feature on your calculator, and let's generate some points. All right, so here you can see my calculator screen, and if you look at the very top line, I just typed in the original equation. That might be the best way to go. Just type in the original equation. Make sure you put parentheses around the numerator and the denominator. All right, and then just go to your table, and there you have your table. And you can scroll up and down to get whatever values that you need. Okay, we're back here on the graph, and I just chose these points for my table. I wanted to choose a couple of numbers that were to the left of negative 4. So negative 4 is the vertical asymptote. So what's happening on the left of that? So I chose points A, which is at negative 9, and point B is at negative 5. And you see the y values here. So here's point A at negative 9, comma 3.2. And point B is here at negative 5, comma 8. So I know the graph has to pass through both of these points, and it has to curve and get infinitely close to that horizontal line here. So it kind of flattens out here, and then it should kind of be a little more vertical as it gets closer to negative 4. All right, so that's what it looks like on that side. All right, now what's happening on the right side of negative 4? What's happening on the right side of this vertical asymptote? Well, I chose negative 3 for x. I also chose 6, and I chose 10. So we have negative 3, comma negative 4, which is point C here. We have 6, comma 1.4, which is point D here. And then we have 10, comma 1.6, and that is point E here. So I know that the graph has to pass through all of these points. So it's going to be close to vertical as it gets closer to the vertical asymptote, passing through point C, x, y-intercept, passing through the hole, passing through point D, and then also passing through point E, and then leveling out as it gets closer and moving further and further towards infinity. All right, so that completes the graph. And now all we need to do is just transfer all of the information down here into these spaces. So let's figure out our domain. Domain is going to go from negative infinity all the way until it gets to this vertical asymptote of negative 4. So negative infinity to negative 4. and then it continues from -4 until it hits the hole, so that hole creates another break along the x-axis. So that'll be union from -4 until we get to 2, that's where the hole is. And then once we jump over the hole, we continue all the way out towards infinity. So that would be union 2 to infinity. All right, that's our domain. Now our range is going to go from -infinity until we get to the hole. Now what is the y value of the hole? All right, since we're talking about range, it has to be the y value of the hole, which is 1. So the range is going to go from -infinity till it gets to 1, where the hole is. And then it will go from 1 until it gets to this horizontal asymptote. Now that horizontal asymptote is going through 2, so that's union from 1 to 2. All right, then we can jump over the horizontal asymptote, and now we're on this curve, and that's going to go from 2 all the way up to infinity. So union 2 to infinity. All right, so this is our range here. All right, then we can fill in the rest of the items from what we've already found up at the top. Let's talk about the increasing and the decreasing parts. Okay, so if you're on this path, you're increasing from -infinity until you get to the -4 vertical asymptote. So increasing there, -infinity to -4, union. All right, and then now you're jumping onto this curve, and you're also increasing from -4 until you get to this hole. So that's from -4 until you get to 2. And then once you leave the hole, you continue to increase from 2 all the way to infinity. All right, so that's where it's increasing. Where is this decreasing? This is never decreasing. It's always increasing. So for decreasing, we'll say never. All right, and then just fill in the rest of the information. We already had our vertical asymptotes from the top. The vertical asymptote was x equals -4. Horizontal asymptote was y equals 2. The x-intercept was -1, 0, and the y-intercept was 0, 1/2. The hole was at 2, 1. And that is all of the information. All right, for graph number 2, in the numerator, we can factor that by pulling out an x, and that's going to be x times x minus 2. And on the bottom, it remains the same. Okay, there are no holes because nothing cancels out. So down here at the bottom where it says holes, we can say none. All right, let's go for our x-intercept next. So to find the x-intercept, we set our numerator to equal 0. Okay, so the x-intercept, you'll take x times x minus 2 equals 0, and that's going to be two answers. It's going to be x equals 0, so you'll have an x-intercept at 0, 0, and you will also have an x-intercept when x minus 2 is 0, which means x would be 2, and your x-intercept would be 2, 0. All right, so your x-intercepts are 0, 0, and 2, 0, and let's go ahead and put that on the line, 0, 0, and 2, 0, and let's go ahead and graph this as well. All right, x-axis there, a point at 0, 0, and another point at 2, 0. All right, so those are your x-intercepts. All right, let's find the y-intercept next. So to find the y-intercept, you just plug in 0 for all the x's. So if there's a 0 here for that x, put a 0 in for that x, put a 0 for that x. You're going to end up with 0 on the top divided by 3, and that's just going to be 0. So the y-intercept is 0, and so that means 0, 0. Well, we already have that point, 0, 0. It's both the y-intercept and it's the x-intercept. So let's just include that in the information down here. Okay. All right. Now the next thing is let's find the vertical asymptote. So to get the vertical asymptote, we set the denominator to equal 0. So if x plus 3 is 0, then x is going to be negative 3. So let's go ahead and put that on the graph. Vertical asymptote going through negative 3. And let's indicate that in the space below. All right, so we have our vertical asymptote there. All right, let's find the horizontal or slant asymptote. Do we have horizontal or slant? Well, the degree of the numerator is 2. The degree of the denominator is 1. So the numerator's degree is 1 greater than the denominator. In that case, we have a slant asymptote and no horizontal. All right, so no horizontal, but we will have a slant. So let's go ahead in the space. In the space, we will say horizontal asymptote. We'll just cross through horizontal and rewrite slant there. Okay, so we have a slant asymptote. Now, how are we going to find the slant asymptote? We do that by synthetic division. So we're going to divide the numerator by the denominator using synthetic. So we put negative 3 on the outside, and our coefficients are 1, negative 2, and a placeholder of 0 because there is a 0 on the end of that. All right, we drop the 1 down. 1 times negative 3 is negative 3. Add those together is negative 5. Multiply negative 5 times negative 3 is 15. And add and we get 15. So our y-intercept, the slant asymptote. The slant asymptote, SA, is going to be the equation y equals 1x minus 5. Now, of course, you know that your remainder is 15, but we ignore that because it's going to be 15 over x plus 3. And when x gets infinitely large, as x goes to infinity, this fraction gets closer and closer to 0, so we just ignore that. All right, so our slant asymptote is y equals x minus 5. Let's go ahead and put that on the graph. Y equals x minus 5, you're going to have a y-intercept of negative 5. So that's this point here. And then our slope is positive 1. So we go up 1 and over 1. And then just continue going up 1 and over 1. And so you have this slanted asymptote. All right. Okay, so where it says slant asymptote here, just go ahead and write the equation there, which is y was equal to 1x minus 5. Okay. All right. What else do we need to find? Looks like we can go ahead and get values for the table. All right, you see my calculator screen at the very top. That's how I typed in my equation, just using the original equation, making sure you have parentheses around the top and bottom. All right, go into your table. There's your table, and you can scroll up and down as needed. All right, let's transfer some points back over to our page. All right, now as far as my points go, I wanted to find out what's happening on the left side of my vertical asymptote. So what's happening on the left side of negative 3? So I picked negative 9 and negative 4. The y values are negative 16.5 and also negative 24. So point A is negative 9 comma negative 16, which is here. And point B is negative 4 comma negative 24, which is here. And we can conclude that it has to stay in between these asymptotes here. And so the graph is likely going to do something like this. Okay, so this gives you a good idea of what's happening over in this section. All right, now what's happening on the right side of negative 3? So I chose point C, which is at negative 2 comma 8. That's this point up here. And I chose point D, which is at 8 comma 4.4, and that is this point here. That's point D. All right, now we can conclude that it's got to stay in between these asymptotes and it's got to pass through all of these points. So it's safe to say that the graph is probably looking something like this. Okay, so this is a rough representation of the graph in this space. All right, now we need to find domain and range. We also need to know where it's increasing and decreasing. So in order to do that, we need to find where the turning points are. So let's figure out the turning points. So now we'll use our technology on the calculator to find the maximums and the minimums. All right, so here you can see my calculator screen, and I'm just using the technology that I have on my calculator here. And if I'm traveling along the curve on the lower part, the lower section, I see that it will snap to the maximum point. So you see that? It snapped right to the maximum point. And in the upper left corner, you can see the coordinates. So the x-coordinate is negative 6.87, and the y-coordinate is negative 15.75. So those are the coordinates of this local maximum. Now, if we do the same thing for the other curve up here at the top, if I'm traveling along this curve, then I see that it will snap to the minimum right there. All right, that's where the minimum is, and the x-coordinate is 0.87, and the y-coordinate is negative 0.25. All right, so we'll transfer this information back to the page. All right, and you can see here that I just have the maximum point here, and it's negative 6.87 comma negative 15.75, and we have the minimum coordinate here, and it's 0.87 comma negative 0.25. So let's talk about the increasing and decreasing. If you are on this curve down here, then you're going up. You're increasing from negative infinity until you get to the maximum point at negative 6.87. So it's increasing from negative infinity to negative 6.87. Then when you jump up to the other curve up here at the top, it starts increasing again at this bottom point, at this minimum value, which is 0.87, and then going towards the right to infinity. So it's going to be increasing from 0.87 all the way out towards infinity. All right, so increasing is negative infinity to negative 6.87, that point, and then union from this point all the way to infinity. That's 0.87 to infinity. All right, where is it decreasing? Well, if you start here at the maximum and then go to the right, you're going to be going down. So that's decreasing from negative 0.687 to until you get to the vertical asymptote of negative 3. So that's from negative 6.87 to negative 3. Union. All right, then now you jump up here to this curve, and you're going to be decreasing from the vertical asymptote, of negative 3. You're going to be coming down, coming down, coming down until you get to this minimum value at 0.87. So between negative 3 and 0.87, you're also decreasing. So we just add that in there from negative 3 to 0.87. All right, and this is your decreasing intervals. All right, let's talk about the domain. The domain goes from negative infinity until you get to your vertical asymptote of negative 3, and then there's a break. It's from negative infinity to negative 3, union, and then it leaves from negative 3, it will go all the way out towards positive infinity. So it just continues out towards the right forever from there. So union, negative 3 to infinity. And that is your domain. Now, as far as the range goes, the range is going to go from negative infinity until it gets to this x coordinate, until it gets to this y coordinate here. So what is the y coordinate of the maximum point? It's negative 15.75. So it will be from negative infinity to negative 15.75 union, okay, and then it will continue from this minimum point here, from that minimum point, and its y value would be negative 0.25, and then going up forever. So from negative 0.25 to infinity is the other part of your range. Okay, so here is your range. Negative infinity to negative 15.75 union negative 0.25 to positive infinity. All right, and that completes the graph for number 2. All right, here's question number 3. This is an equation, so these two fractions are equal to each other. First, we can go ahead and factor the first denominator. That's going to be q minus 8 times q minus 2. We can factor this numerator as well, and that's going to be 2 times q minus 2. Now these the q minus 2 on the top can cancel with the q minus 2 on the bottom. So now what does that leave us with? So we just have the 2 here, and then we have the q minus 8 there, and then we have 2 over q plus 2 there. Well, since we have one fraction on the left and equal to another fraction on the right, we can now cross multiply. So if we cross multiply this way, we're going to get 2 multiplied by q plus 2. And that's going to be 2q plus 4. Okay, so 2q plus 4 equals, and then we'll cross multiply this way. So you're multiplying q minus 8 times 2, and that's going to be 2q minus 16. And now if we subtract 2q from both sides, right, minus 2q on both sides, then the two q's will just cancel each other out on both sides. And that would just leave us with 4 equals negative 16. Now we know that that is a false statement. 4 does not equal negative 16. And since that is a false statement, then we can say that there is no solution to this problem. Okay, so the correct answer is no solution. All right, number 4. So for number 4, we do not have just one fraction equal to another fraction, because we've got two fractions over here on the left added to each other. So what we'll need to do is find the least common denominator and multiply the entire equation by that. Well, the x squared minus 25 will factor into x plus 5 times x minus 5. So this is actually going to be our LCD. So now we're going to multiply each of the fractions by x plus 5 times x minus 5. So if we do that with this first fraction, times x plus 5 times x minus 5, then we're going to get the x minus 5 on the bottom, canceling with the x plus minus 5 on the top, and that leaves us with x plus 5 times 1. Well, and that's just going to be x plus 5. Okay, plus, then if we take this second fraction and multiply by our LCD, then we're going to get the x minus 5 canceling with this x minus 5 again, and that leaves us with x plus 5 times 1, and that's x plus 5 again. And then on the right side, if we multiply this fraction by x plus 5, x minus 5, we're going to get the x plus 5s to cancel, and we're going to get the x minus 5s canceling. So the only thing left is x plus 3 on the right. Combining like terms, that's 2x. And adding the two 5s, that's plus 10 equals x plus 3. Now let's subtract x from both sides. That's going to be x plus 10 equals 3. And now let's subtract 10 from both sides. So that would be x is equal to negative 7. So that should be our solution. And if x is negative 7, it does not make the denominators become 0. So this is going to be okay. So our solution is x equals negative 7. All right, here's number 5. We can factor the x squared minus 1 into x plus 1 times x minus 1. And that is going to be our common denominator. So we're going to multiply each term by x plus 1, x minus 1. So x plus 1, x minus 1 multiplied by this fraction here, that will cause the x minus 1s to cancel, and then you're left with x plus 1 times 5x, and the result of that is 5x squared plus 5x. Now we'll multiply the negative 2 times x plus 1, x minus 1. And of course, when you distribute the x plus 1, x minus 1 back together, then that becomes x squared minus 1, and then go ahead and distribute that with the negative 2. So negative 2 times x squared minus 1 is going to give you negative 2x squared plus 2. And now when you multiply this last fraction by x plus 1, x minus 1, then the x plus 1s cancel each other, and the x minus 1s also cancel, and you're just left with the 14 on the top. Combining like terms, 5x squared minus 2x squared is 3x squared. Then you bring down your 5x, and then you have plus the 2 equals 14. And now let's subtract 14 from both sides. So we're going to get 3x squared plus 5x minus 12 equals 0. Now maybe we can factor this. 3x squared plus 5x minus 12. Well, 3 times negative 12 is negative 36. What multiplies to negative 36 but would also add up to 5? And that would be positive 9 and minus 4. So we can take this and rewrite that as 3x squared plus 9x minus 4x minus 12 equals 0, and then factor by grouping. In this first group, we'll pull out a 3x, and that leaves us with x plus 3. And then in the second group, we can pull out a negative 4, and that leaves us with x plus 3. And so now we end up with, let's move to the top here, we'll end up with 3x minus 4 times x plus 3 equals 0. So our solutions are going to be x equals positive 4/3 and x is equal to negative 3. All right, so those are our two solutions there. And neither one of these solutions will cause the original denominators to be 0, so they are good solutions. So again, x equals 4/3 and x equals negative 3. All right, here's question number 6. We have these two fractions that are equal to each other. So we can cross multiply, but before we do that, let's go ahead and factor the numerator and the denominator. The 3x plus 6 can be factored into 3 times x plus 2, and x squared minus 4 can be factored into x plus 2 times x minus 2. These x plus 2's will cancel on the top and bottom. So now we've got 3 over x plus 2, or x minus 2 equals x plus 1 over x minus 2. All right, if you cross multiply, you'll be multiplying 3 times x minus 2. That's going to be 3x minus 6. Cross multiply this way, you're multiplying x minus 2 times x plus 1, and you'll distribute that. So that's going to be x squared minus 2x plus 1x minus 2. Collect your like terms. That's going to be x squared minus 1x minus 2. Let's make the left side become 0. So that'll be x squared. Subtracting 3x would be minus 4x. And adding 6 would be plus 4. Okay, so now what multiplies, can we factor this? Yes, what multiplies to 4 but adds up to negative 4 is negative 2 and negative 2. So we have a solution. It's actually going to end up being one solution because it's the same. It's x minus 2 equals 0, which means x is 2. So we have one potential solution, but be careful. Notice if x is 2, what happens in this denominator? If x is 2, then x minus 2 becomes 0, which means that fraction becomes undefined. So we thought that there was a solution of x equals 2, but it isn't, because it makes the fraction undefined, and therefore there is no solution, because x cannot equal 2. So no solution. All right, number 7. All right, so in number 7, we want to multiply everything by the LCD, and the LCD is going to be 6x squared. So we multiply that fraction by 6x squared, and that causes the 6x squares to cancel, leaving you with 1. We'll multiply this by 6x squared. And what will happen is the 2 will go into the 6 3 times, and the x can go into that x squared, and that will leave you with an x there. So you end up with just 3 times x multiplied by 1, and that's 3x. Plus And then the last fraction gets multiplied by 6x squared, and that causes the 6x squareds to cancel, leaving you with 7. So we have this equation, 1 equals 3x plus 7. Now solving for x, we'll subtract 7 from both sides. So 3x is equal to negative 6. Divide by 3, and x is going to be negative 2. And it does not make any of the denominators become 0, so this is a valid solution. All right, number 8. We can factor in several places, but let's factor the denominator. So in the denominator, we can factor the x, v squared minus 5v. We can pull out a v. So that's v times v minus 5. Same thing here, v times v minus 5. So what is our LCD? Our LCD is v times v minus 5. So we're going to multiply each fraction by v times v minus 5. Okay, so when you multiply this first fraction times v minus 5, the v's cancel each other, and that leaves us with v minus 5 times 1, which is v minus 5, plus, all right, and then we're going to multiply this fraction times v minus 5, and that causes both the v's and the v minus 5's to cancel, leaving us with 3v plus 12. Bring down your equal sign, and we're multiplying this fraction times v minus 5, and everything cancels out there. The v's cancel, the v minus 5's cancel, and we're just left with 7v minus 56. Collect like terms. We have v and 3v makes 4v. Negative 5 plus 12 is 7. And on the right side, we have that 7v minus 56. Let's subtract the 4v from both sides. So subtracting 4 from 7 leaves us with 3v on the right. And now let's go ahead and let's add 56 to both sides. 56 plus 7 is 63. 63 equals 3v, and let's divide by 3, so v is going to be 21. That is a valid answer because it does not make any of these denominators 0, so v is 21. All right, and that concludes Unit 7 Review Number 1.